You know, the air we breathe indoors, we just kind of take it for granted, right? But here's the thing, it's not an accident. The quality of that air, whether a room feels fresh and cool or just stuffy, is the result of this whole hidden world of engineering, complex rules, and very deliberate design choices. It's like an invisible architecture all around us, and it's shaping our health every single day. Oh, we've all been there. You walk into a meeting room or an office, and you can just feel it. Something is off with the air. Well, that feeling, it's not just in your head. It's a real sign that the invisible architecture of that space might be letting you down. And that's the key idea to grab onto. Indoor air is a managed system. It's governed by a whole set of standards and rules, all designed to keep us comfortable and, well, healthy. So today, we're going to pull back that curtain and really understand how this system is designed, where its weak spots are, and how it's being forced to evolve. All right, to get a handle on our air, we've got to start with a foundation. I want you to think of it like a layered shield protecting us. And this first, most fundamental layer, it's the everyday rule book that dictates the air quality in pretty much every building we use. So let's get the official definition on the table. Ventilation. Notice, it isn't just about blowing air around. The key word here is control. It's all about actively managing what's in the air, the contaminants, the humidity, the temperature, to keep things at an acceptable level.
The industry Bible for this, for most buildings anyway, is ASHRAE Standard 62.1. The simplest way to think about it is like a building code, but for air. And its main strategy is actually really simple. Dilution. You just bring in enough fresh outdoor air to water down all the common pollutants that build up inside, from people, furniture, you name it.
And this standard gets really practical about where that fresh air comes from. It's not enough to just say, bring air in. You have to bring in clean air. So the standard sets out these minimum distances, making sure your building's air intake isn't right next to the dumpsters or a truck loading dock. I mean, it's basically just codified common sense, right? You don't want to suck exhaust fumes right back into the building you're trying to freshen up. Okay, so that's the baseline. But what happens when the problem isn't just everyday stuffiness? What happens when the threat is an invisible, infectious aerosol floating through the air? Well, that's a fight our baseline standard was never really designed for, and the COVID-19 pandemic made that terrifyingly clear. This quote from the new Standard 241 is wow. It's really telling. It says that for about 100 years, our standards basically forgot about controlling the spread of disease. They shifted focus to things we could immediately sense, like odors and general stuffiness, what they call perceived air quality. And that historical blind spot is exactly what left our buildings so vulnerable and created this urgent need for a whole new playbook. And that new playbook is Standard 241. Its central idea is something called Infection Risk Management Mode, or IRMM. Honestly, the best way to think about it is like a fire drill plan, but for germs. It's a pre-planned emergency mode that a building's systems can switch into during a public health crisis, specifically to knock down the risk of airborne transmission. And this is a huge shift in thinking. On one hand, you have Standard 62.1, which is for normal, everyday life. Its goal is basically comfort and making sure the air doesn't smell bad. But then you have Standard 241's emergency mode, which has one single laser-focused mission: reduce the risk of people getting sick. Comfort suddenly takes a backseat to safety, and you start using much more aggressive tools like heavy-duty filtration and air disinfection. Now, to do this, Standard 241 gives us a new way to measure things: equivalent clean airflow. This is so important. It recognizes that clean air doesn't have to be fresh air from outside. You can actually create clean air inside the building by taking the air that's already there and scrubbing it clean with high-grade filters or zapping it with something like UV light. So, to hit the much higher safety targets you need in this emergency mode, you build up your defenses. You start with your baseline of outdoor air from the normal standard. Then you add on the cleaning power of really good filters. And on top of that, you can even layer on disinfection technology. All three of those things stack together to give you your total equivalent clean airflow. So we've got a baseline for everyday comfort and an emergency protocol for a pandemic. But what about the oldest, most intuitive method there is? This brings us to the third part of our story: the simple, beautiful act of just opening a window. And it's a totally fair question, isn't it? With all this talk about complicated machines and filters, if the goal is just to get fresh air in and bad air out, why not just bypass all the tech? Well, it turns out that just opening a window is way more complex than it sounds. See, natural ventilation isn't magic, it's just physics, driven by two main engines. First, you've got wind pressure. The wind literally pushes air into the building on one side and creates a suction that pulls it out the other. Second is something called the stack effect. We all know hot air rises, right? Well, as the warmer air inside a building goes up and out through high windows, it creates a gentle vacuum that pulls cooler, fresh air in through lower openings. But of course, there's a major trade-off. The pros are huge. You save a ton of energy on fans, and people are generally happier when they have control over their own window. But the cons are just as real. An open window has zero filtration. It can't stop wildfire smoke, pollen, or pollution. It lets in street noise, you lose privacy, and forget about controlling the temperature. It really is a constant balancing act. And this is where the real design challenge smacks you in the face. Different spaces have wildly different needs. A typical office might need just over half an air change per hour, but a classroom packed with kids, that needs 3 air changes per hour. Trying to design a building that can naturally provide that much ventilation reliably for every single room is an incredibly sophisticated challenge. So, after all that, where does this leave us? We've got our baseline for comfort, our emergency mode for safety, and this natural alternative that's powerful but tricky. The future of truly healthy buildings is all about understanding how these different pieces can and should fit together. It all comes back to that layered shield. Standard 62.1 is the foundation. That's your non-negotiable, everyday minimum fresh air. Layered on top, you have Standard 241, your emergency protocol, ready to activate powerful air cleaning when a real threat emerges. And woven through it all is the option of natural ventilation, a sustainable, desirable path, but one that demands really smart and careful design. So, the big takeaway here is that the air you're breathing right this second is not an accident. It's the product of 1,000 tiny decisions made by architects and engineers, constantly balancing your health against your comfort, energy use against the cost to build. It's a system that's designed to be invisible, but trust me, it's always there. And that really leaves us with one final big question. Our world is changing fast. We're facing new health threats and a climate that's becoming more and more unpredictable. The question we all have to ask is whether this invisible architecture that surrounds us, in our jobs, in our schools, in our homes, is going to be ready and resilient enough to truly protect us in the future.